Let's do this problem right here. The question is asking, solve the following system of linear equations, write the solution in vector form, and state whether the solution is a point, a line, a plane, or a three-dimensional space. So let's do this. So first of all, I have to take the matrix form. So let's take this. It's going to be 4 minus 6, 8 minus 2, and here we have minus 1, 3, minus 2, then here we have 1, minus 3, 9, minus 6, and 1. On the other side we have 3, 2, minus 5. So to solve this system I had to do the Gauss Jordan. So to do the Gauss Jordan, it's better to bring the symbol pattern. For example, this is 1. So it's better to bring this one to the top and solve this. That will make everything easier. So I'm going to swap this one with the first one. So the first one will become minus 1, 3, minus 2, then 1. The other side is going to be 2. Then the second one is going to be 4 minus 6, 8, minus 2, 3. The third one is going to be minus 3, 9, minus 6, 1, minus 5. Now what I have to do is I have to make this one into positive. So to do this I have to multiply everything by negative. So if I do that I will get 1 minus 3, 2, minus 1, and here is going to be minus 2. Then the second one remains the same, so it's going to be 4 minus 6, 8, minus 2, 3, minus 3, 9, minus 6, 1, minus 5. So let's continue here. So now to eliminate this one, so in Gauss Jordan we had to bring everything below and above the pivot to 0. So to do this one I had to I'm starting from the bottom. So to make the bottom one 0, what I have to do is I have to multiply the first one by 3 and add it to the third one. So let's do this. 1 minus 3, 2 minus 1, minus 2, and here we're going to have 4 minus 6, 8 minus 2, 3. If I multiply the first one by 3, it's going to be 3r1 plus r3, which will give us 0 in the third one. And if I multiply this one by 3, it's going to be negative 9 plus 9 is going to be 0. And then 3 times 2 is going to be 6, 6 plus minus 6 is going to be 0. Then 3 times minus 1 is going to be minus 3 plus 1 is going to be minus 2. And here we are going to have 3 times minus 2 is going to be minus 6 plus minus 5 is going to be minus 11. Then what I can do is I can eliminate the second one. To eliminate the second one, I can multiply the first one by negative 4 and add it to the second one. So if I do that, I will get 1 minus 3, 2 minus 1 minus 2, and I'm multiplying the first one by negative 4, so it's going to be negative 4r1 plus r2. So if I do that, I will get 0 right here. Then minus 4 times minus 3 is going to be plus 12, plus 12 plus minus 6 is going to be 6. Then minus 4 times 2 is going to be minus 8. Minus 8 plus 8 is going to be 0. Then minus 4 times minus 1 is going to be plus 4. Plus 4 plus minus 2 is going to be 2. Then minus 4 times minus 2 is going to be plus 8. Plus 8 plus 3 is going to be 11. So this is the value we get. Then the third one, I can also simplify this. The third one by, I want the 1 here because we are doing the Gauss Jordan, so I have to bring it to 1. Therefore I have to divide this one by negative 2. So if I divide this one by negative 2, I will get 0, 0, 0, 1, and I have to do this to the other side too, so it's going to be 11 over 2. Then what I have to do, the second one, this one is a little bit complicated form, like 6. I have to make it into 1, so I can divide this one by 6 to make it 1. So let's do that. So if I do that, 1 minus 3, 2 minus 1, minus 2, and if I divide this one by 3, I will get 6, I will get 0, 1, 0, and 2 by 6 is going to be 1 by 3. Then other side we are going to have 11 by 6. Then here we have 0, 0, 0, 1, 11 by 2. So now what I can do, I can eliminate this value to I can make this one into 0. To do that I have to make this multiply this one by 3 and add it to this one. So let's do that. 3r2 plus r1, which will give us 1 0. Then here we're gonna have 2, then 1 over 3 times 3 is gonna be 1. 1 minus 1 is gonna be 0. Then we have here 3 times 11 by 6 is gonna be 22. 22 minus 2 is gonna be 20. 3 times 11 by 6, actually 11 over 2, so 11 over 2 minus 2 means minus 4 over 2, so minus 4 over 2 means 7 over 2, so 7 over 2 right here. Then 0 1 0, 1 over 3, 11 over 6. Then we have 0 0 0 1, 11 over 2. Now what I have to do, I have to make this one into 0, because we know that in the Gauss Jordan we have to eliminate all the value above and below the pivot to 0. I have to make it to 0. So in this case, to make this one to 0, what I can do, let's think about this. So first of all, I'm copying this down, 1 0 2 0 7 by 2. So to make this one into 0, one thing I can do is I can divide this one into negative 3. So if I divide this one by negative 3 and add it to this one, this will become 0. So let's do that. So minus r3 by 3 plus r2. So which will give us 0 1 0. This is going to become 0. Then I have to do the same thing to the other side. So this is going to become minus r3 by 3 is going to be what? Minus 11 by 6. So minus 11 by 6 plus 11 by 6 is going to become 0. And that's wonderful. It's making everything simpler. And then the third one is going to be 0 0 0 1 and 11 by 2. So now we reached the final level. We brought this one into Gauss Jordan pattern. Now we can directly solve this equation. Now also we can recognize that this is our free variable, because this column doesn't have a pivot. So this is our free variable. Let's call this one x3. Yeah, they are taking x1, x2, x3. So this is x3. x3 is free variable. Therefore I have to give the answer in terms of free variable. So let's do this one. So x1 plus 2x3 is equal to 7 by 2. In the second equation we know x2 is equal to 0. And the third equation x4 is equal to 11 by 2. So from this one, the first one I can I can write this one in terms of free variable. So this is going to become, if I solve this one, x1 is equal to 7 over 2 minus 2x3. So now I have to write everything in terms of free variable. So let's write this one. 7 over 2 minus 2x3. Then x2 is going to be 0. x3 is going to be itself because it's a free variable. And x4 is going to be 11 by 2. And if I take the x3 common, this is going to be minus 2. In this one we don't have free variable, so this 0. We have a 1 x3 right here, it's 1. And we don't have any x3 right here, so it's 0. So this is the final answer. And also this, they are asking, state whether the solution is a point, a line, or a plane, or a three-dimensional space. If you see, this is a one vector. The dimension is 1 because we have only one vector. And also it according to the free variables we can determine the dimension. If we have two free variables, the dimension is going to be 2. So since this one has dimension equal to 1, it's a line. Therefore this is the line. And that's how we answer this question. I hope you guys like this video. See you next time.